Hello guys, welcome back to my channel Code by Vansh, and today we are going to solve the two questions. One is merge two binary max heaps and another question is actually does array represent heap. Okay, so let's first solve this merge two binary max heap question, then we will move forward at that question. Okay, so in this question we have given two binary max heap as array. Merge the given heap to form a new max heap. Okay, so first of all let me tell you about what is a heap. So heap is actually like a tree structure. A heap is like a tree structure which follows two property. First property, well, there are two type of heaps. One is max heap and another is min heap. So it depend upon either it is a max heap or it is a min heap. So let's take an example of a max heap. So max heap, like it, because it is a tree, it has nodes. Okay, so let's take an example. This is a node, this is a node, and this is a node. So if this is a node and it is connected like this, so as we all know that the upper node is always called as a parent node. So this is the parent node, and this node and this node is actually a child node. So this we can call as a left child and this we call as a right child. So this is actually a heap structure or a binary tree structure because one parent has two child. So this is a binary max heap. Okay, now what are the two conditions? So first condition is that the parent should always be greater than its left child and right child. Okay, so this is the max heap property, the first max heap property, that the parent always has to be greater than max left as well as right. So this is the first property, and second property is that it follows CBT. So let me tell you about CBT. What is CBT? So CBT is actually complete binary tree. Okay, so a binary tree is like this. We always fill it from the left side. We always fill from left side. So this is a binary tree. Okay, so this is a binary tree. This is a complete binary tree. Okay, we can say this is a complete binary tree. But if we make a structure like this, like this, so we can see that after filling this, we will fill left and then right, then we will fill left and then right. But here we can see there is not a node. So that's why we can say that this is not a complete binary tree. So in complete binary tree we fill from left to right, then we fill left to left and then right to right. So that's how we are actually going to do this. So if it is a heap, then it follow two property. One is this property and second is this property. So now let's move to this question says that I have my heap as this and I have my heap as this, so I need my final heap like this. So how actually we are going to do this? So one is the array like this. What I am going to do, I am just going to combine both of these arrays. Okay, I am going to combine both of these arrays, which is actually the heap. Okay, so my new array will contain 10, 5, 6, 2, 12, 7 and 9. So this is my new array, and now this is just a random array. Okay, this is just a random array. So in order to make it what you say a max heap, what I'm going to do, because max heap priority queue is actually a max heap, so that's why I'm just going to insert everything in this priority queue. I will make a priority queue data structure and I will insert everything inside this priority queue data structure. And then what I'm going to do, I'm just going to return this priority queue. Okay, so that's why it will give me answer. Here in the code also you can see that I have pushed every element into my A. Okay, after I push every element into my A, I am just going to make a priority queue, and then I am just going to push every element to the new A. Like this is the A dash, so I will push every element into my PQ, and then I am just going to check the top. and I am just going to pop it out. Okay, and then at the end I am just going to return it. So this is the whole procedure on how we are actually going to merge two binary max heap. So now let me move to the second question. So the second question actually says that we have to check if our array represent heap or not. Okay, so we this is a really easy question or a basic question. So in this type of question we have actually given like this array, and this array we have to convert it into the binary heap, binary heap or a heap. Okay, so we just need to check if it is a heap or not. And whenever heap is mentioned, there always says that this is a max heap. Okay, so we have studied that the max heap has actually two properties. One is they are always CPT, and second, the parent node is always greater than the left node as well as child node. Okay, so let me tell you one thing, that if I am a parent node, okay, if I am a parent node and I have an index at I, so my left child and my right child index would be 2i multiply 2i multiply uh, 2i plus 1, and right child will be 2i plus 2. So this is the thing we have to remember in order to solve these type of questions. Okay, just remember this thing. Okay, and in this question also we are going to use it. Okay, because this is a tree like this. Okay, and when we actually convert it, so this is I. Okay, so this is I. So I am just, because this is a root node. Okay, so after I draw this root node, this is 90. So 2i, so 2i plus 1. Okay, 2i plus 1 would be 1 and 2. Okay, because I is actually 0, so that's why 2i plus 1 is equal to this. So my left side would be 15. As you can see, left side would be 15 and my right side would be 10. So this is the thing. And after I move to this one index, 2i plus 1, 2i plus 1 would be 2 multiply I plus 1 would be 3, which is actually here it is 7, and 12. This is the child of 15, and then at the end 2 is actually the child of 10. Okay, so we are going to check at each node if the parent is actually greater or not. So this is the parent here, and I can see that 90 is greater than 15 and 10, so it satisfies this condition. And I will just move here. I see that 15 is actually greater than 7 and 12. This is also true, and this is the leaf node. So let me tell you one thing, that all the leaf nodes are actually from n by 2 to n by 2 to n. Okay, in the array all the leaf nodes are from n by 2 to n. So this is the thing. And as you can see here, what I'm going to do, I'm just going to do it like this. Like I will traverse the array. So this is the coding part. Here in the coding part you can see that I am just traversing the array. I am just here, and I am, if this is the child, because at the end it is all the child nodes. So at the child node I'm just going to check if my child node is greater or less than. So as you know that if this is my child node, this child node always has to be less than the parent node. Okay, so whatever comes at this position must have been greater. Okay, and if it's not greater, which is this condition, if it is not greater, then this means that the condition is false, else it is true. So these are the two things, and it is always complete binary tree as it is given. Okay, so I hope you like the video. Make sure to like, share and subscribe for more upcoming videos, and thank you for watching.